Let's look at how you can develop your own Astro Zombie Horde and bring them to life. First of all, we need to develop some geometry and rig it. To do that, I'm using Tencent Hunyuan 3D version 3.0. We have the option of a single image to 3D or multi-image to 3D, which is great if you have front, back, left, right views. This will take any image and build a 3D model for us. The latest version 3 offers up to 1.5 million poly count for higher fidelity results. After running tests later, I realized that the 1.5 mil is pretty heavy, and the quality from the 500K count really isn't too drastically different. If you can see our first Astro Zombie, he's been bit in the leg, but nonetheless very zombie-like. Here we can see the image input, and for all of these I use the single image input. Overall, the results aren't bad at all. The web viewer allows you to use some lighting tools and look at various shading channels. You have many different export options too, which is nice for portability. The channels are a great indication of detail, but again, at 1.5 million poly count, it's a very heavy rigged asset. Our next Astro Zombie is a bit more obvious look. If we look at this reference image, a lot of the features are captured. You can see the bones generated for all of these characters seem pretty good so far. Of course, we don't have a hand, so the animations will be a bit limited, but these are Mixamo rigged bones, so we'll be able to extract them easily when it's time to retarget. Now let's jump over to Quick Magic and take a look at the motion capture from our mobile device. This solution is pretty awesome because you can take videos from your phone, or really cool shots from online or anywhere, and you can use them to drive the motion capture data. It is free to sign up, and you can get some starting credits before you subscribe monthly. There's also a ton of different output options, which gives you flexibility for your rigs. Let's take a look at setting up a file. Once you upload a video, it selects your subject for you, and then you can select which rig style you'd like. I typically select the Mixamo, but I recently discovered the C4D and the Mixamo are both the same, but it has C4D orientations. But with the Mixamo, there's a new iterative and quality feature added to the 2.0 Mixamo generation, so I'll stick with that for now. Next, we can choose the parameters to help guide the motion data. I choose the T-pose, so I can align the reference pose to the Astro Zombie's T-pose, and this provides a perfect T-pose for the first frame only. Some of these settings are based on your video, but this new physical optimization iteration multiplier, from what I've tested, runs about 2 times as many credits from the version 1. But the results do feel slightly better with some organic motion. At the bottom we get a cost estimation as well before we commit. This helps us understand how tweaking the settings can affect the overall cost. Now that this is running, we'll take a look at some of the simple captures I tested earlier. What's interesting here is even though my cat comes into the frame and walks around, the capture holds pretty well. I did have to fix an ankle joint, but we'll take a look here shortly how to fix those and tweak those. When reviewing mocap, if you like the way that things are looking, all you have to do is click the download button, and then it'll download an FBX so you can port that back to your DCC. Quick Magic also provides some free demo and test data. So here's a look at some previous test footage, and it has some pretty solid results. Now the videos are processed, let's take a look at the Mixamo first, with the new 2.0 motion capture. The results look pretty good, honestly. The feet, the hands, the gestures, they all feel pretty nice. And now let's look at the C4D version. The results are good here too. I'd have to pull them into the same scene and really compare, but all in all we have some good quality results in minutes. Now let's take a look at this video with some more dynamic motion. We start off pretty solid, but as soon as you lose sight of the feet in the frame, it just doesn't know what to do. So this is luckily where there are some tools to help refine, and let's take a look at those tools. If we click on the 2D refinement icon, we hop over to a new window and refine the data. There are KP and IP modes, and they each have some different guides. We'll just take a look at the KP for now. Each foot has 4 points or locators, and they do a great job when the feet are visible. Unfortunately, when they're not, they get thrown all around awkwardly, and so do the hips and some other points. In hindsight, something to really save some time and energy would probably be to re-record from a different angle, almost maybe a side profile. But we can take a look at fixing this, and how you can use these tools because it is fixable. With different points selected, there are some frame interpolation features, and those help you so you don't have to go frame by frame. But if you'd like to go frame by frame, you can, it's perfectly fine. For the interpolation to work, you would find a good spot at the start and then a good spot at the end, where the points are aligned. Then the interpolation would tween between those start and finish points. This can be tedious though if you have several areas throughout the long animation that do have issues. But if you spend 15 to 20 minutes and really correct those parts, it should correct the mocap data pretty well. Definitely make sure you save your changes so the mocap changes take effect. But luckily we're not actually using this captured data for this experiment, so I'll just skip this for now and come back later and refine more. So let's dive into retargeting in Cinema 4D. With all my Astro Zombies lined up already, we can clearly see the joints and the T-poses, and this tells us that we'll likely have a successful retargeting opportunity. I also have a figure here just to look at real world scale, because I believe the figure is sized as 6-foot human. All of these characters are relatively the same height and proportions, so that's good. I did notice that the weighting of the characters isn't perfect, so even in the T-pose there is a bit of stretching and deforming in the arm areas and tension areas across the body. One way to help resolve this globally is using a Delta Mush. The Delta Mush has several uses, but it can be great to help mitigate artifacts when using things like deformers or rig characters. So we'll use that in each of these guys, and we'll place the deformer after the skin deformer. And the skin deformer is telling the geometry to bind to the joints. For the Delta Mush to work properly, we have to initialize first with the skin deformer disabled, so it can store the initial point information. That way it knows how to interpolate the stretching and deformation. And you can see it makes a pretty big difference. And this is also procedural, so we can go back and change the mode, we can change the strength, and we can even change the smoothness amount. That gives us additional flexibility. After we apply that to all of the characters, the next thing to do is define the joints properly, and we'll use the character definition tag. And that tag can be found in the rigging tags. This is an important step because all the characters do have the same joints, but they're uniquely weighted and applied, and they all need defined for the mocap data to bind properly. If we click on the tag, we'll see the Open Manager, and that's what we want. If we click Extract Skeleton, all of the joints that are children are located and placed in their correct area. This is important because many rigs use the same joints, and with mocap data we need to ensure that the right joints move in the correct ways. If the joints aren't located from the Extract button, we can always go one by one and drag and drop them into the correct categories, but that can be very tedious. Once we have the joints all identified properly, we can click Set Reference Pose. This is an important step to make sure our mocap can align accurately. So we'll do this extraction on each character. Now let's import our Quick Magic mocap FBX data, and we'll see the Mixamo rigs for all the joints. It's always smart to play through or scrub just so you can see your mocap data is working. I'll rename them just to keep things organized, and I'll just move them up a little bit to align with the Astro Zombies. With both these mocap data sets, we'll do the same thing as before. Apply character definition tags and set the reference poses. You might notice that these characters are defined with more joints, and that's because they have hands and fingers and such, and that's just fine. It won't be a problem at all. Now let's just isolate one of the Astro Zombies to test things out. I did have the naming backwards, so I'm going to go ahead and swap those really quickly. And now it's time to create the character solver to retarget the data from the mocap to the Astro Zombies. Since we already have the character definition tags with the joints defined, and our reference poses set, we can just use the tag itself to create the solver, and as soon as we click on Create Solver it gives us a new tag. In this solver tag, we can see the Astro Zombie is already slotted into the target. We just need to drag and drop the definition tag from the mocap data to the source. And there we go. It looks like things are actually working. I chose this specific model first because I already knew it had limit issues on the shoulders and on the suit. And we're going to take a look at how to quickly mitigate those issues with some constraint objects. If we toggle open our joints and we locate the shoulder joints, those should be what we need to make some tweaks. With both right and left shoulders selected, we can convert to nulls. This command is found in the Character Commands menu, but I personally dock this to the palettes because I use this a lot. It's a really powerful command that essentially just creates nulls, but it comes in handy all the time. Now we're going to use these new nulls to drive local offsets to account for the Astro Zombie shoulders. If we select the original shoulder joints and then we go to the rigging tags, we can add some constraints. With these constraints, we'll enable transform, and then we'll click on the transform tab. We have to enable maintain original, so these added transforms calculate in addition to the mocap data. And now we just drag the newly created nulls as targets, and we should have a nice link created. So now we can tweak and rotate and translate these shoulder joints, all by using the nulls. And there we go. Quickly tweaked, and we can always go back and tweak some more, or we can key them throughout the animation in various ways. So now that we know this works, we can test it out on all the other characters with the same process. Create a character solve through the definition tab, and drag in the same mocap source definition into the solver. Each character may also need their own localized tweaks, but now we know that's not very difficult, and that can be handled with some simple constraints. We can apply this same idea to the rest, and now we have a synchronized zombie crowd. So let's take a step further and look at motion clips. If we open the asset browser and type mocap, we'll get a large list of 115 to be exact of motion captures for all Maxon users. If we scroll to the end of the list, we'll see 3 zombie presets, so let's add all 3. As soon as we add these into our scene, we'll see a couple things. 1, they already have character definitions. This is great. 2, they're staggered and offset from each other, so that tracks with these all being start, middle, and end captures that can be combined for a whole sequence. Right now we have all the previous mocap data linked, so in order to update these to the characters, all we need to do is replace the source section in the solver with the new mocap data from the asset browsers. And I'll do that now for the zombie start mocap. Unfortunately, we don't get the walking motion added, but that's okay. We can key the Z position later and make it work. For now, we have to merge all these into one, and then apply that to the Astro Zombie. Since we already have a nice link with the solver on the start mocap, we can just build motion clips into the start animation to include all 3. Let's do that. So with the start mocap selected, we can go to the animate toolbar option, and then select add motion clip. This gives us a little pop-up that shows us how many frames are inside the animation, 106.5. And we're going to want to enable the remove included animation from the original object, so we can redefine the mocap with the motion clips instead. For the other motion clips, we don't need this enabled. And we're going to do the same thing and create a motion clip for each object. So now that all of our mocap data is converted to clips, we can hop into the timeline editor. If we select the motion clip tag on the start mocap object, we can click on the open in TL, and here we'll build out our motion clip animation. It's important that we adjust the motion clip on the start mocap, and not the others, because the start is the one that's linked to the character. On the left side we have all of the motion clips, and if we drag and drop onto the timeline along with the start that's already there, we can build onto it. Each of these clips should overlap a frame or 2, or even more, so they can ease from one to the next easily. For these clips it works nicely, but if we need to shift or adjust, we can always add a pivot in the advanced section. For example, if we add a motion clip in from the quick magic captures, we'll see a misalignment, and even strange rotation. If we click on this motion clip and go to the Advanced tab, we can enable the pivot, and the pivot provides a nice gimbal, where we can align and transform our mocap data to match the others. With the Ghosted Bones view, we can see the motion path, and we can use that as a guide to help us align the motion clips. But ultimately, these 3 pre-made captures work really nicely together, so we can leave those 3 paired together to provide a pretty nice zombie stroll. Now we just have to animate on the Z, so our zombie walks. Since the mocap data already indicates with these ghosted views where the zombie movements are at the start and the end, we can simply key the Z position from the start to the finish in a linear fashion. And that should do the trick. And now we can hop into Octane and add a bit of extra interest. We can do some procedural blood spatter with the newly added rest attributes. Since these AI 3D models have terrible UVs, we have to work around that. This means we can use the rest attributes tag and store point information to lock in textures along the animation. If we map a noise with box projection and clamp the noise, we can mix a bloody red shader and add some nice organic blood spatting, independent of the poor AI UVs. And this will hold nicely throughout the zombie walk. Plus it's procedural, so we can add this to each zombie in unique and unlimited ways. I like to enable and use the diffuse filter AOV, and then I can practically see in real time without lighting influence, and it helps for visual placement. Once everything's looking pretty good, we can push these shader settings off to the other zombies. And then we can push to the render network, via the new Cinema 4D wizard. Through either the Render Network Manager app or the web app, I can send all of my zombie scenes to render at once, and all 1200 frames will take a fraction of the time it would take locally. With the front-end development and quick iterative generations with AI to the back-end support through the Render Network, you can animate and bring your characters to life in days, or even faster. Try the Render Network today and build your own zombie horde.